And I'm live. Today is 17th of July 2025. What? Thursday. Today is Thursday. And in the last 1 week, I have only streamed once, which is bad and which is pretty bad. And the excuse that I can give is that I was sick. I still am a bit sick, but I can stream. But that was not the problem. I was looking for a valid excuse so that I can stop streaming because it was getting hard and it was getting real. So when I got this real excuse, that is a fever, I stopped streaming. I used that excuse as an excuse and I used that unfairly and I didn't stream, which is bad. Uh, yeah, I will not do that again. I will not do that again, and I will stream consistently from now on. Yep, because if I do not do that, not just streaming, but if I stop doing the things that I do, if I stop doing the hard things that I try to do, then what is there? Nope, nope. So yeah, I'll just stream now, read chat, and solve questions, and stop my mini video there. CB31, and yeah, Tmux ls nothing. Now Tmux set. Now Tmux ls. There are 4 sessions and Tmux attach to CP competitive programming, and this is now I would like to go to 1100 folder. Yep, I wrote some code for this, I guess, last time, and 1100 here also. And let's see. Yep, I was on question number 3, but I do not remember how it was. Collecting games. Collecting games, this one. And okay, okay, I got this right? Uh, Copy. uh, CD 11 and RM are we collecting games, and there are some updates in lazy, and I hope my voice is clear. Yes, it seems it is. Yeah, we collecting games. Click right here, CP, and shit. Now, boilerplate, and then paste the code here. And due to some reason, I do not have lines on the left, and a wrong answer, even though I cannot see the answer. Be collecting games. Yep. Yes. So I was in the middle of solving this, and I have a cool new zooming thing. This is cool. This thing, zooming in out. You are given an array A of n positive integers and a score. If your score is greater than or equal to AI, then you can increase your score by AI and remove AI from the array. Okay, if my score is greater than AI. For each index I, output the maximum number of additional array elements that you can remove if you remove AI. If you remove AI and then set your score to AI. Note that the removal of AI should not be counted as the answer. Okay, and okay, so I need to have the order this my score is already 5, so for 20 it will become 25, and 25 is greater. If my score is once greater than the smallest number, then uh, if my current score is, in this case, 25 is my current score after removing 20, then I can sort the remaining numbers. And what will be the thing for that? I can sort these and the maximum number of elements. So individually or in a row, I can add all of these because all of them are less than 20. Okay, and when this is the thing, then it becomes equal to 10, and then I can add this 3 is the answer. And when this, then it becomes 6. And why is it 0? I should be able to add this and this independently. Why is this 0? It is 3 for this, and you're given an area of integrals. If your score is greater than or equal to AI, then you can increase your score by AI and remove AI from the array. Then I can increase my score from AI. For each test case, input the height, which denotes the maximum number of additional array elements that you can remove if you remove AI from the elements, and then set your score to AI. Okay, additional array elements that you can remove if you remove AI from the element, and then set your score to AI. Am I setting my score to AI? So if that is the case, then what is the point of this number? For each AI output, the maximum number of additional elements. You can increase your score by AI and remove AI from the element. For each first line of each test case. And okay, shit. My bad. Okay, this is n. That is the number of things in here. So this has nothing to do with these. This is just n number of things. And if I start with this, okay. Mm-hmm. For 4, it is this and this, and also something else. 5. So it is okay. It is adding numbers. Okay. So first I will take the smallest number, then the second greater, then the greater. Okay. Mhm. And in this case, answer would be, if I take the smaller and then the greater, right? So it would be 2, but it is 1, because if I add the smaller to this, it becomes 2, 4, 1, which is greater than 4, 2. Okay. And here 0, of course, and here 4 in all the cases. Okay. So I need to sort it and create pairs. Sort all AI. Lambda function return first, make first smaller than the second. Okay, and after that I will create a array size n, which will have the answer vi answer size n array. And about this, yep, this is good, this is good, and yeah, this is good. And sort all then create an answer, and after sorting I will insert into answer for every place and then output it. So how do I find out the answer? In the first place is the position, and the second is this. Second is the position, first is the value itself, and it is sorted. Oh shit, and I would need a running accumulative sum. Okay, and what are the limits? N can be pretty big, and this can be pretty big. So I think here I'll do it long. Uh, int 6 as accumulated sum starting at 0, and yeah, that would be it. And then, oh shit, not just that. Yes, it is sorted, so I can go. Yes, okay. I 0 n, and how do I find, okay, accumulative sum, if accumulative sum is, and also the current index. Yes, in C count initially is 0. Uh, and C would represent how many from the starting I have included in the current thing. How many numbers from the starting I have included in the accumulated sum. And I starts at 0, goes up till n, and, and then accumulative sum is 0. Okay, if accumulative sum is lower than, maybe I can go higher. Okay, yeah. Why accumulative sum is lower? Yes, because I want to make it higher or equal. If it is equal, then can I add it? The score is greater than or equal to. So even if it is equal, then I can add it. Uh, can add it. So I want to get to a condition where I cannot add it. So which is this. But I will also add. Oh shit. Okay. So accumulative sum will be added to the current number. At some point, I will add a number which will not make me greater than this shit. Okay, so 1, I add 1, it becomes equal. So I can still add 1, but 1 is 1. So for the smallest, it is always 0. So I will start from 1, and answer 0 is 0 always. And then what can I do? Yes, others. 1, I'll go to the next element, and I can accumulate some. So there are two sums which are running. Shit. With this, I add this to this accumulative sum to the current number and compare it with the next greatest, which is 4, and 4 is greater than accumulative sum plus the current number. so we can leave it. And then the next is 4. So and accumulative sum at that point we will take it up to till it as far as we can, right? While yeah shit counter maybe instead of making this a variable I can make this a vector and 6 accumulative sum of size n, and then here I 0 n yes I equals, I'll start the first one at yes I yes I 0 equals a I minus 1 plus a bracket I as a bracket I dot first, and initially as 0 equals to the first number, first smallest first, and start this for 1. Now I have an accumulative sum array. Now another loop starting from the second element. Keep on traversing it at the smallest to the current number and see if it is smaller, and keep adding it. I think I'm making this more complicated than it needs to be. 1 second is the time limit. Hmm. In j equals 0 and while s j while s j is lower than s j plus a I dot first. Uh, let's go for 5. For 5, I add the smallest is j. It starts at 0, so 1 is smaller than 1 plus 5. Then I add the next one, 2. It becomes 3, and 3 is smaller than 8. Yes, plus this j plus 1 plus 1. So and answer he starts at 0 initially, while j lower than n, and this while j lower than this, and then while j is lower than n, that is this true, and while j plus 1, n minus 1, while j plus 1, I'm checking if I can add another one, right? So that is cool. ai dot first, okay, and c plus plus, j plus plus. If this thing does not hold for even, yes, but before that I have to see, can I add even the smallest number? And I do not want to add this 5 twice. So, and j is not equal to, yeah, if j is not equal to I, only then increase c. Otherwise, do increase j. And when that happens, I will cross this, and es would also include 5 in this summation. But should it include 5? I am here, let's say start from 0, it becomes 5 plus 1. Is 5 plus 1 greater than this? So think c equals to 1. Uh, yes, j is smaller than or equal to ai dot first question mark. If that is true, then I can add it. So 1, otherwise 0, and if I cannot even add the first one, then no point in going through this. Then this seems very bad. No, okay, I can fix it later. Yes, j, and then I am checking for every j. So 5 plus 1, is it, if it is greater than, should, why am I checking for sum? I have to check for a here instead of the sum. Yes, instead of the sum, I have to check for a. Yes. Yeah, cool. Not first. Check for the next number. So 2 is smaller than 5 plus 1. Then add. Then I am checking 5 plus 1 plus 2. That is 8. Is it smaller than, is it greater than 4? It is. So go in and increase the count by 1. Count becomes 3. And j becomes greater. That is, j comes to 5. And when j comes to 5, I check the condition and I loop out. I do not increase the counter. And then I go to 20 and I see, is 20 smaller than this, and here j is greater than I, so I have to subtract 5, subtract ai dot first from j. Shit. Minus I, if j becomes greater than or equal to I question mark, then subtract ai dot first else 0. This is bad. And after this while loop, I will have the c, the counter. For this, I can add it answer e I dot second equals c, and then another loop. So, right here, yes, another loop to output the answers. So for auto x answer, c out answer, and space. Invalid operands to binary. C using namespace. Invalid operands to binary conversion versus string, aka basic. Return x then space, and then at the end. Think that is wrong, and it does not end. So yeah, it is wrong. I mistake is in this. While I have C, while J is lower, and I am incrementing J in every term, so it should not be like this. Which problem? This one. Code forces problem number something something. Okay. So I am recording a macro. Problem number this. Problem this. 1401904B. Answer A dot second C out. TLE time limit exceeded because of this part, or because of sorting, not because of this part. Let me out. C out. C. I didn't save it. Now it doesn't work. Line plus plus B action games C output 5, let's say. Shit, no. Number of test cases, just one. 5 elements in the array, 25, 1, 4, 2. And it does not work. Okay, so it is not coming out of this loop. Is it getting into that loop? And of switch out 1, 1, 2, 0, 5, 1, 4, 2. It is not even getting into that loop. Shit. Maybe it is something else. Why t minus minus t should be 1. Okay. This should work. And of course, I am very, very stupid. Do this. Let's see now. Answers differ. Line not slash out. 1 5 20 5 1 4 2. And answer is this. For 20 the answer is very big. Then 4 is correct. No, it should be 3. 0 is correct, that is fine. Then it should be 3, then it should be 2. Okay, it is wrong for the last number. Last number for n, last is n minus 1, so j starts at 0. And c++, this should return 1, while c and this and this and these, all of them have to be true. So this to move on. Equal to I. Right, I am storing I here. Index for answer, and that is correct. Why did I output 2 in the case of 2? That is also one problem. Yeah, so 2 is the second number, and after that g equals 0, which is the accumulative sum. Which is the accumulative sum. And while this is lower than n minus 1, because I'm in space, I can start at 1 and make j go up in this and check for this element and the last element, the last sum, and that and subtract this if j becomes greater than or equal to I at any point. Okay, and this is 0, quite a lot of zeros. One, five, five, 1, 4. Okay, it is wrong, of course. Why sorting the answer first is always 0. Limit thereof, which is the accumulative sum, first is equal to the first, and then starting from the second element, ai equals the last one plus the current element. And then starting from the second element, because we know the first one is always 0, start at j equals 1 and count is equal to 1 or 0 depending on this condition. Not yes, this, that should change few things. Yes, it does. Okay, this seems like the first one in all the test cases is messed up. This one is correct, this is correct, this is wrong, this is correct. Yes, this is wrong. The one for 4. Cause why? Because in 4 j starts at 1 and counter is equal to 1. Okay, and then j is less than n, yes it is, and aj dot first should be j1, it should be 2, and 2 is 2 smaller than j minus 1, that is 1. 1 plus the current element 4. This 2 is smaller, though therefore I increase j and I increase counter. J should not be equal to I. Is that the reason? Then I go to 4 and okay, and 4 is 4. The next number is 4. So I do not increase j, I just increase j. Then I go on to seeing the next one would be 5. Is 5 smaller than a j minus 1, which should be at this point 1 plus 4 plus 2, that is um, uh, 7, and 7 plus a dot first, that is 4, 13, and 13 minus j greater than this is j greater than equal to I, and it is greater than equal to I. You know when it is. Maybe I broke my code at this. If it is equal, then it becomes equal to 4, and 4 is smaller. Okay, and then so not at equal. This should result in something better. Yes, that is correct now. And now the first one is always messed up due to some reason. Why? Answer. This first one is always messed up because why? I'm going up till n. There are garbage value there. Answer n minus 1 equals 0. Again, that does not change anything. Which game? Okay, I see chess icon. Do you play chess? Yes, I play chess. Jatin. Yes. J7. Int j equals 1, c equals yes, camera and stuff working. Yes. AI dot first. When am I coming out of this game? See out, see, and this line dot slash out. 1 5 0 5 1 4 2. Yeah, my bad. 1 1 1. See out, see. Shit. 4 3. Shit. That was the mistake. I had see out, see here at this place. That was the mistake. And why do I have a 0 here? The, the first one is not always 0 because okay, makes sense because it might be equal to the next one. So I can remove this, and start from 0. Does that change thing? I will always start J at the next one. Let's see. It does changes things. Yeah. So let's say uh, cannot be. Yes. First one. With the count int c equals to question mark something. If I is greater than 0, first of all, I is greater than 0, and then AI first is greater than or equal to as 0, either this or this is the first element, in which case just don't do anything. That's question mark 1 is 0. 10204. Okay. If it is the first element, then I have to move on. Yes. So I can remove this. I cannot directly remove this. Okay. I have to go into this only if C is something, and the next one, then also yes. If the current element is either not the current element but the current sum, which is at this point only the current element. It is the problem is only in the case when the first one is equal to the second element. First element is equal to the second element, and yes, that is the only problem. Well, just check for that. This or if this is greater than one thing, should int c. No. If I not equal to 0, if I is not the first one, then c equals to ai has to be greater than or equal to the first element, which is as 0, and ai not first. Else, if it is the first element, then check it whether it is equal to the second element, second greatest element, in which case it will c equals I ai, like there's 0, so a 0 dot first equals a 0 dot a 1 dot first, and here add c. Hmm. This one is still wrong. Okay, so this is the only one that is wrong. After this, I am adding this, assuming this is smaller than this. 1, 2, 3, and here. Okay, so this is smaller. These two are smaller than these two, and here after this first is equal to the second. Here, yes, it is already in ascending order, so I can move on. C is something, and J is lower than N, and E J dot first, which is this, is this less than this, less than accumulated sum of, which is just this, and AI dot first. Okay, so it can be even equal to it. Now it is fine, and everything else is correct. Yes, everything else is correct. How did we put this up to 5? Uh, how can it even be equal to 5? Oh shit, yes, because made C equal to 1 and then it traversed through 4 elements which it will be adding. Okay, so I can make um, is this while this or this, and C, and this is very wrong. This is only a bit wrong. More wrong than before. Bro, can you share your women convicts? Yes, it is on GitHub. // github.com/mining slash nvim rc. I think that is the name of my repository. It is misbehaving for one, the smallest element here, and in this case this is the smallest, and this misbehaving for the second element in this case, which is the smallest, so it is misbehaving for the smallest element in every case now, because I made it less than or equal to. Yeah. Still, uh, either C or this thing and this thing, and I equal to 0. Um, there is still wrong. Yep, still wrong. Why is this big? While either C or the first one is equal to the second one, in which case C should initially be equal to 0. Okay, now we are almost good except for this one. And what is the problem? So first one is equal to the second one, and I is equal to 0. I will be equal to 0. I am checking for I is equal to 0, so I'm at the smallest element. Okay, and first one equals to the second element. Okay, and j is less than n, and this and equal to, now we are free. Now we are free. Everything is correct. Okay, and now I can submit. Right here. Submit. I think this submission is faster than choosing a file. And that is, yes, Jordan Peterson in the background. Running on test 3 and TLE on test 3. 100 more than a second because there are a lot of numbers. So yeah, time limit exceeded. Now I will be looking at the editorial for this one. I will be looking at the editorial for this one because it has taken more time than it should have. I have given it 50 minutes, which is a long time. 50 minutes is a very long time. Tutorial for B, collecting sum, collecting game. So let's sort array A. The answer for the largest number n minus 1 is, the answer for the largest number is n minus 1 because the score, which is a n, cannot be smaller than any of the other elements. Now consider the second largest element. The answer is at least n minus 2 because every element that, okay, so is that confusion or what? For this the answer is 0. For this, when I begin with this, I should be able to add this and this and then this 5. That is why the answer is 3. For this, only this. And I can never add this. For this, I can add both. And here the answer is 4, only because I added these two first and then I moved on. Now consider the second largest element. The answer is at least n minus 2 because every element that is not greater than n minus 1 can be taken. That is not greater than n minus 1 can be taken. Yes. Then we check if the score is at least an. At least n minus 2. Okay. Okay. So for 4, the score is at least 1 and 2. I can add both of these always. Then I am looking for how further from 4 can I go higher. And for that, I will be comparing this, the next greatest number, with the sum till now, with the running sum. So I can change this. After sorting these, yes, from pairs, I will have to create pairs, no way around that. And then I do not need this, no this, no this. I do not have to loop again and again. And I can remove all this. And for en, let's make, no, don't make anything. I know I will be running from the, let me sort it in reverse order. Okay, and the current element is the greatest element and the sum is at least, if I yeah, the sum is at least the length. Okay, no, yes, I will make it like this. I'll just return the way I'm looping. For n I equals n minus 1, I greater than or equal to 0, I minus, and int c equals at least I, right? Yep, I should be at least I, and then I want to go greater than I, and for that I would need the accumulated sum till now. Alright, yes, I would need the accumulated sum till now, which I can just take when I was taking the input. So, and here, int 6 s equals 0, and after this s plus equals ai mark first. And here I will have the maximum sum. So after this, s minus equals the current number, which is I dot first. After this, sub, I do not have to subtract the current number. That is cool. I have to go higher. Int j equals I plus 1, and then while j less than n, and a j dot first is smaller than rs, which is running sum. I will do something, and instead of creating a running sum every time, it's int 6 running sum is equal to 5 is less than rs, and I have to do uh, first count plus plus, and rs plus equals aj dot first, and j plus plus, because I will be going higher. Okay, I wish this. Okay, and for here, for 20, it will go out of range, so nothing will happen. Then for 5, this will become equal to 20, and I will be checking if 20 is lower than rs, and rs is the sum, and after this s minus equals ai dot first, and after every iteration rs becomes equals to s, and s, so it will remove 20, and then I will see is 20 lower than sum till 5, and the new counter increases by 1, and rs, I will add this number to rs and g plus plus. Okay, that is cool. That seems correct, or maybe not, because I didn't input. Yes, sure. After this, answer ai dot second equals c, and that is correct except the last one. In the last one, okay, something went wrong for this one. So what the running sum would be, the start was this, then when I came to this was subtracted, so the sum was this much, then the sum was this much, then the sum was this much, and then the sum was this, less than or even equal to. Okay, cool. Submit. Let's see. It is running. Time limit exceeded. Okay. So I'm messing something up. Why? N can be pretty big, it seems. When is this? When is the number? Okay. And if I'm sorting them, then it will take a long time to sort them. 5. Sorting would take n log n, and log 10 power 5 would have 5 digits. So 5 multiplied by 5. So that is not big. It should be done in correct time. Then I'll do this answer. And do I need this? I think I do need this. I think the overhead in comparing each element here is pretty big. So let's go to the tutorial. Solution. Now consider the second largest element. The answer is at least n minus 2, because every element that is not greater than n minus 1 can be taken. Then we check if the score is at least an. Score is at least an plus. This inspires the following solution. First, we find the prefix sum p of array A. We calculate the answer in descending order of AI. To calculate the answer for an AI, we find the largest J P prefix sum, largest J, where this is this, and set the answer for I equal to the answer of J, equal to the answer of J. This inspires the following solution. First, we find the prefix sum P of array A. Then we calculate the answer in descending order of AI, starting from the right, the greatest element, and going down to the smallest. To calculate the answer for an AI, for ith element, to calculate the answer, I have to find the largest J such that the prefix sum is greater. Okay, makes sense. And set the answer for AI equal to the answer of J. And I suppose by answer of J, then equal to J itself. And this is one indexed, not zero index. If it was zero index, then the answer would be J plus 1. Shit, Bunny. Push back, other first, second, one of the crazy stuff, and then this. P from CN PI plus pair, and I taken I, and that is first, and second is I itself, that is what I did. Then sort them. The first r plus 1, what is PII, what is PII? Pair of integer, array of m, okay, and then sort ARR, which is a pointer, ARR plus 1. Okay, yes, makes sense. That is the first element, and ARR and plus 1. Okay, okay. That is the last element. Sort them. Then next, and sum, and okay. Is it because I am using a vector and this person is not using a vector? PI, pair of integer, A of size size n, yeah, and then e comma e plus n minus 1, or e plus, yeah, e plus n minus 1. Yes, and in this variable length, cannot create variable things here. Wrong answer. Let's do variable. Why am I creating this b? But what the heck even is b? Shit, was that the error? I was creating b, something called b. Do that. Submit. Time limit exceeded. Time limit exceeded. Okay, so I will just move on to the next one and try to do this later on my time, or maybe some later date. A subarray is a continuous part of array. Yarik recently found an array A of n elements and became very interested in finding the maximum sum of a non-empty subarray. Shit. However, Yarik doesn't like consecutive integers with the same parity. Consecutive integers with the same parity, so the subarray he chooses must have alternating parities for adjacent elements. For example, this is cool, acceptable, but this is not acceptable because 2 and 4 have the same parity, both even and adjacent. You need to help Yarik to find the maximum sum of such a subarray. I can just keep moving for, and there are no negative numbers. There are negative numbers. Fuck. Fuck. Okay, I do not know. There is the algorithm, Cardace algorithm, I guess. Uh, to find maximum sub maximum sub array. Cardane's algorithm. Yeah, it works in log of n. Does this? Do this for n nums max ending. Have a counter so far, which is minus infinity at the starting, and the current one. So ending maximum of maximum ending here plus num or num, either the current number plus the current number or the sum till now, and maximum so far is maximum for plus maximum. Huh. I can do that, and I would only add when the parity is different. So let's see. Boilerplate 16. So it's not like aligned really well. and person B address and then let me first write a basic maximum array algorithm using Cardin's theorem Cardin's algorithm. I think it does not apply with negative numbers. The algorithm work with negative numbers. We ever have a negative? All the elements in the array are positive. The maximum is the entire array. Ah, shit. Yes, if all are positive, then the maximum is the entire array. Yes. And after this, so wait, int 6. So max, which is initially int 64, min int and min 64 int 64 int 64 min and a running sum, which is rn initially 0. Now I0 goes up till n and rn equals maximum of the current number C current number C or Rn plus C. What maximum? It takes in two numbers. Then both of them, okay, at least one is big number and the other is a smaller number of that. 6. Yes, now we are cool. And then max equals max of Rn or Mx. And then after this, in one test case, see out Mx, then line, as expected. Yes, so I have not added the limitation. Okay. About parity, I will only add a new number when there is a parity, and if not, then don't. If if okay, for this I would have okay, repeat L VIA and I0 N and of size N and N A I and then loop and starting from the first one. Simple, yes. Starting from the first one. Yes, but don't go maybe to the last one. No, I can go to the last one. Starting from the second one and mx till now will be equal to 0, and Rn will also be equal to a. And here, checking the parity of the last one and the current one. If if ai remainder 2 not equal, if it is not equal to a I minus 1 remainder 2. If the parity is different, I can add and do the normal things, which is Rn equals maximum of Rn plus n, Rn plus ai or ai, and I will get an error. I will get an error because we vector int 6 of size n. If this is this, else if not, then Rn becomes equal to ai, and mx equals maximum of Rn comma ai. Mx, yeah, wrong answer for these two. Why parity of these, this is different. The sum here, the maximum sum till now would be 5, and then here I cannot add these two, so I have to look here and cannot add these two, so it would be 10 till now. Then I cannot add all of these. No, I can add 7 to 10 minus 1, but that doesn't mean anything, and cannot add these two because they are the same parity. No, 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 no. 9, no, no. Still the greatest sum is, and the greatest sum is 10 till now, and then come 6 minus 1 plus 7, which is cool. It is 12. So greatest sum till now is 12, and I did output 12. Minus 1 and 7 have different parity. Okay, bad. So it is for giving me error for negative numbers. Let's see out plus minus 1. Okay, it is outputting minus 1. Right, cool. I can submit this one. Let's see. Vijit Mangal. This was randomly on my feed. Strange. Very strange indeed. Wrong answer on test one is crazy. Because it was giving the right answer here. Expected 15, found 28. Expected 15 in the first one. We found 28. Okay. All are positive, so we are cool. 15 and 28, the difference is of 13. And this 15 would be the answer. 4 plus 5 plus 4, 9, 12 plus 3, 15. Why was it? Okay. Oh, no, no. Computer बोलता absolute value and then find the remainder with 2. If it is not equal, then do this. Otherwise, if the remainder with 2 is equal, then do that. Int 6. No. But it is outputting the right answer here. Submit. No. Problem. I have to add the problem. Yes. Let's see. Running. It is running. Shit. So something is wrong with code forces. Only in the first. No. Also in the. Is it because of the way I'm doing this? Vector int 6. I'm taking an input like this, which is blue. Which might not be cool. Taking input directly into integer 6. And if I do this, I get an error here. And running sum, this only this has to be integer 6. So I can make this into long. Now we are cool. Okay, and let's see. Submit. Wrong answer on test one. Now it is 28 or 27. How can it be that? How can it be 28? I'm adding additional 13, which would mean I'm adding what, all of these elements or these elements twice. No, 13, so all of except this, these elements. I am only adding AI if Rn is no. I am only adding if their parity is different. If their parity same, then Rn becomes equal to AI, which is cool, and maximum of Rn or the current number. This should always hold, and Rn becomes equal to AI. Rn plus AI, I am starting at the second element, and Rn is already equal to the first element, so it should become equal to 3, and 3 or mx, maximum of Rn or mx. Mx is also initially equal to that, so mx should become equal to 3. Then I am adding 3 And when I'm doing that, I'm checking its parity with the last number, which was 2 and is different. Therefore, this thing works. Shit. What is the error? Next, is it the way that I'm outputting? Let's see. What are the limits? Well, mm, limits for, so it can be big. 2 power 5, it does not. That the sum of n for all test cases does not exceed 2 power 5. So I do not have to take integer int 6. Can be just normal this and int shape. Was it? It was minimum. So oh, cool. Yep. And submit this. Submit. Paste. Submit. Let's see. Shit. Okay. C++ Pagnu. How long have you been doing CP? For 23 streams. Lex Friedman. Hello, bro. I'm new in CS. Which language should I go with? From where? Uh, on campus higher placement. You're saying, yo, you can have your conversation. That is good. Again, a wrong answer in the first one. Shit. Is it int 6? Mm. Paste, submit, and if you want to start from scratch, you can go here. CSFT. If you are a beginner, then this is the best thing you can do, and this is what I did. This is what I did. This is a free course by Harvard called CSFT, and you can go there and you can learn. 1 hour 29 minutes, and again, wrong answer on the first try. 28. That is crazy. 1, 2, 3, 4, 5. So is it just me? Or the answer wrong for everyone else also? I don't think about the noticing. Problem C. There are bad positions in the array, that is those on which two numbers of the same parity are next to each other. Note that all matching segments cannot note that all matching segments cannot contain such positions in matching sequence. In other words, we need to solve the problem of finding a subarray with maximum sum on some number of non-intersecting subsegments of the array, the boundaries of which are between two neighboring elements of the same parity. Yes. Rn, how can let's see. We'll go to ChatGPT. Specificity is an refresher course which will introduce different things about CD, CS. Yes, I took it and it was amazing when I started coding. Then why are there two partitions? This is my submission for a problem on CF, and I am getting the correct answer locally, but not on the server. Is there some syntactical subtle mistake? Let's break it down carefully. Answer for this code is good for each test case and read n into n. Teachers initialize mx and rn to a0. Yes, then iterate from 1 to n minus 1. If current and previous elements have different parity, extend rn with ai if beneficial. Otherwise, make it restrict to this and then update ourselves. Looks fine logically, and local errors gives correct answer. But false int uses without including C limits. If you are got C limit, you may not find C limits. That should not be a problem because should be here. How do I go to definition? Go to GP. RC, LSPs, plugins, LSP config. Go to definition is okay, control and right bracket. Okay. Like this. And do I have limits here? I do have limits here. So that is cool. That should not be a problem. Scan. Shit. Is it scanf? You're mixing scanf with input output C in AI. Input buffer issues. Shit. I think that was the problem. Submit. Paste. Submit. That was the problem. Accepted. It. Yeah, Strivers course. That is what I am doing. right here. This is accepted. That is cool. Before moving on to the next problem, I would like to read this editorial. The problem of finding a subsegment with maximum sum can be solved by using classical algorithm with keeping minimal prefix sum on the prefix. On the prefix, the problem can be solved in a single pass over the array by simply dropping the values. Shit. Hmm. Solution. Okay, I am still sick. Okay. Yes. Intend take an input and create the array and minimum minimum and sum is this, and okay, we're looking for the maximum. Minimum either 0 or this. No, I can just take a0. That wouldn't fine. For I equals 0, yes, starting from the first element, plus plus. If absolute, yes, I have to do absolute. Remainder 2. If the parity is same, then min 0, sum 0, and okay, that is cool. That's cool. That is what I did. And now I can move on to the next question after refreshing this. 250,000 tons of TNT. Let's see. That is a lot of TNT. Alex is participating in the yo. Alex is participating in the filming of another video of Mr. Beast, and Mr. Beast asked this Beast asked Alex to prepare 250,000 tons of TNT. Okay, but Alex didn't hear him well, so he prepared n boxes and arranged them in a row, waiting for trucks. The ith box from the left weighs AI tons. Okay, all trucks that Alex is going uh, to use hold the same number of boxes denoted by K. Okay, loading happens the same way, the following way. The first K boxes go to the first truck, the second K, okay, and the last K boxes go to the N by Kth box. Okay, upper limit of this. Yes, the upper ceiling of this thing, N by K. Upon loading is complete, each truck must have exactly K boxes. Okay, so n is exactly divisible by k. In other words, if at some point it is not possible to load exactly k boxes into the truck, then the loading option with that k is not possible. Alex hates justice, so he wants the maximum absolute difference between total weights of two trucks to be as Alex hates justice, so he wants the maximum absolute difference between the total weights of two trucks to be as great as possible. If there is only one truck, this value is 0. Alex has quite a lot of connections, so for every k, he can find a company such that each of its trucks can hold exactly k boxes. Print the maximum absolute difference between the total weights of two trucks. Okay. And for every k, okay. The first line contains okay, so I can sort them t and then n the number of boxes and then an, okay, and it is guaranteed that the sum of all n pieces does not should have been 25,000 tons, not 150. Okay, this is cool. This is cool and doable. Into 6? Yes. Molar plate, 17, and 10, N, and then A, VI, V, size N, left L, I, 0, N, C, AI. After taking the input, I have to sort all A, and then after that, after sorting, okay, I will look through I or K starting from 1 to N. It can even be equal to L. Yeah, no, less than. If N, if not N remainder K, if there is no remainder, that is N perfectly divides, then I have to see the sum of the first K boxes, and for which I do not have to actually do this. I can just create an accumulative sum array. Vi and sum will not be very great, so accumulative sum N, and initially, so okay, let me see this, and I replace with 0 starting at 1, and also as 0 equals a0, a0, sorry, and 0, a, I, and as I plus equals the last one and the current one, as I minus 1 plus a I, right? So in answer initially 0, and then answer is maximum of answer, comma, the sum of the last key elements, which would be, and I know that it does not overlap, because at max k will never be equal to n, because I have taken that. Yes, and k will be at least 2, so in which case the sum would be accumulative sum of the last element minus accumulative sum of n minus 1 minus k, so that I have removed k elements, right? That would be the sum of the last elements, and from that I have to subtract the sum of the first k elements. So yes, k is this, the problem might be 0. uh, k minus 1, because we are going 0 index. 0 index, yes. And then see out answer to the new line, and that is wrong. Cool. Let's see, 0 0 0 0. Because I'm stupid. Because yes, Hmm. Should be this should be correct. Yes, n minus 1 gives me the accumulated sum of the last element, and then from that I am subtracting yes n minus 1 minus k, this sum. So I have the sum of the maximum element. So maybe I sorted it. I sorted it the right way, right? 1 1 2 2 2 2. My bad. Mm, mm. It is sorting in the right way. N divided by k. So in this case, shit, it is the first k boxes go to the first track. Okay, okay. So I do not sort. This was stupid. This thing is stupid. Yes, because I'm sorting data and I'm making the accumulated somewhere before. So this does not matter. Why am I like unconcerned with A? So I have to find the maximum sum and the minimum sum. So this thing is true. And I would need the accumulated sum array. Mhm. For the current k, and this would increase the time complexity. It is already without any loop. It is well n. It is already n for this much, and now I will introduce a loop which will go for this will become n square. Yep, this will kind of become n square, and is it maximum this? So yeah, I do have the leeway, I think, of going n square. So let me do int mx is int minimum, and int mn is int max, and for int I equals 0, I less than equal to n, I less than n, and I plus equals k. I will be leaping with k. If k is 1, increase 1, go to the next one. Okay. And mx equals to, how do I find the maximum? Starting from this ai to the sum of the x. Okay, for this, I think I can make this n plus 1 and as 0 equal 0, and yes, make this 1 and I plus 1, and yes, I k And why did I do that? Okay, I have a good reason. Maximum of the maximum, or s of I plus k, that is the next one if it exists, or next one minus as I minus 1. And I will start at 1. Yes, unique computer. That is maximum, and minimum is minimum of minimum and the current one, which is this. I minus 1 will not give me any error. No. And but this I plus k could give me an error, because I could land outside the limit. Initially I am at 1, and case 2, then for second element I should land at 3, and I will go to 3. Yes, shit. Minus minus 1. Yes, yes, this is correct. And the answer is maximum in mx minus mm, comma, answer. Answer to that. C, and that is the correct answer. I think this will work for all the other cases also. Let's see. Submit. Mr. Beast. Yo, any 2022 grad here. Bro, this Harvard course will help in what ways? Yo, hello. This will get you up to speed in what is programming and what you can do in programming. It will just tell you about what the basic things are, what is a computer, what are binary things, and how you can code, what actually is coding, and how not to get a wrong answer. Shit. Oh. Mm. Sign integer overflow. This is too big. Okay, this was not supposed to be too big. With range 6. And here I will have to make some changes. Convert this into 6. This might break other things. It does not break other things till now. Let's see. Yeah, when I took it, I was also a newbie, so no problem. Go on and take it. Wrong answer, number 4. Expected this, found this. This is a bigger number than this. It's 3 and 3. Yeah, this is a bigger number. So answer still has to be 6 and 6. Let me just match it all up. And shit. Okay, the dot command RDW and this. Yeah. Vim shortcuts. And after this, what seems good. Something is wrong. This in 64, 64, 64. Uh, Wait, I could have used the dot command here, like this. Uh, Wait. If this was like this in 64 and this. Shit, it does work. Uh, does this work? Yep. Submit. Hopefully it works. It does work this time. Accepted. That is cool. For learning C++, I have to learn C. Yeah, I mean, C is a subset of C++, and do not think of it as if you are doing something hard, and do not avoid these things. These things are important. And C is a very, very simple language, very simple language. Like it is very close to the computer hardware, not very close, but pretty close. And it would benefit you to learn C. And if you're learning C++, C++ is very complex and it has a lot of vocabulary. Every thought that you have in your mind, you can express it in C++. There is like a ton of different things in C++. Let me actually show you. You can see this book, this thick book. This is the reference for C++. This is written by the author of C++. So this is the book to learn if you want to learn C++. Right, and the book through which you can learn C is this. This is this thick, and for C++, the book is this thick. So there is a difference, and if you want to learn this C++ and you are afraid of learning this, it is very unreasonable. So, if you are planning to learn C++, learning C would be very easy. And now, one more question, at least one more. Deja vu. You are given an array A of length n, consisting of positive integers, and an array X of length q, also consisting of positive integers. Okay. There are q modifications on the ith modification for each j between this and this. Okay, for every element, such that aj is divisible by 2 power ai. Okay, ith modification for every element, it is divisible by this. You add e minus 1 to aj. Okay, note that ai xi will not increase, will always be less than 30, so 2 power 30, a positive integer not exceeding 30. Okay, after all modifications, you need to output the final array. Okay, there are few modifications. I have two arrays. One is my array and second is modifications. Okay, this is my array and then this is the modification, and for each element here, for each number here, I go through every element there and I raise 2 to the power of 2 because this is 2, and if any one of these is divisible, then I make it equal to 3. Okay, and then 2 power 6 and this. about 4, nothing. So the answer, our final answer should be 1, 2, 3, 3, 3. But it is 1, 2, 3, 6 pound. 6. Why is it 6? Minus 1. 2 to power 2 is 4. You add this. Okay. So I add 3 to 4. Now I add 2, the earlier power of 2 to this. Okay. And okay. Makes sense. So odd, I will not never touch any of the odd numbers and all the numbers that are not a perfect power of 2. So I will only work with numbers that are a perfect power of 2. Yeah, only the numbers that are a perfect power of 2. That those numbers will be the concerned ones. Like here 8 and not just, yeah, even if they are divisible, that would be cool. Right? Divisible by 2. Okay. So that would be an even number. This. All of these could change depending on this, and 10 would not mean anything. 10 places 64 bits. Okay, 30 is cool. 30 was the limit. Yes, because I'll be using integer. Okay, and 4 and 2, 2 power 4 is 16, and 16 divides this thing. So this would change and it will become equal to 6. This plus 8, that is 50 and 56, and then in the next iteration with 2. So do I want to go through this forever? What is the leeway? Deja vu. The limits. Sorry. Q. Okay. N and Q can be pretty big. And the time complexity that I have in my head is N into Q, which is N square, which is 10 power 5, 10 power 10, which is it acceptable? I think it is, it could be acceptable. Do I have to simulate everything? No. Is there any other option other than simulating this? Uh, hmm, hmm. Other than simulating this, first of all, hmm, boilerplate 16. Fix this. MRC, Vmaps, in this tab is not good enough. I like tab, yeah. That seems cool. Go back. So mrc source where back in boilerplate, and now it is cool. Now it is cool. Yes. Wait, moving on. Ah, shit. One, two, three, four, five, six, eight. Source delete VLP, and now it is fine. Yes. Uh, the tab spacing was wrong by one space. And in here, int n, n, n and q, n and q, and then the numbers vi, a, size n, and I, n, again to ai, and then x of size q, I, 0, c, cn, q, I, fuck, and q, x, I, and now powers of 2. If they are smaller, mm, then smaller than n square. Is there any other algorithm that is better than n square? It's even like looks horrible. I 0 n for every integer. I'll go through that integer, and I j 0 q. I'll go through all of the numbers. Yes. If so, if a I is like no remainder with a I when divided by 2, because it is 2 raised to some power, right? So I can do 1 left shifted by how much on by x j amount, and if that is the case, if there is no remainder, then ai plus equals a plus equals 1 left shifted by x j minus 1, and minus 1 is in this thing. Right, and keep on doing that. Yes, and at the end, output auto x in a c out x with the space, and then that says correct answer. which is empirically, yeah, but I think it is very, very unoptimized. Submit, submit, see, it is running. It says time limit exceeded on test 3, yeah, because it is very, very unoptimized. How can I optimize it better? Still some way. How to make this run faster, faster. AI, and yes, today's also a code forces competition, which is crazy cool. And yes, there is Jordan Peterson. Code forces contest. This one in just 3 hours 47 minutes. And yeah, it will be cool. Let's see what happens. Screen. Because I have to think of something more optimized. Uh, Skeletor. Yeah, I have some numbers. So this and some queries. So I have numbers and I have queries. What do I want? If the number is odd, then I have nothing to do with it and I can actually skip it. That would be a bit optimization. And I can suppose that it is half of the time the numbers are odd, but I cannot suppose it because the test cases will be optimized in such a way that they are there to beating. So if not AI remainder 2, if not AI remainder 2, only do this, then not remainder 2, that is it is even. Only then do this. And number is 2 bit. Then we have to, so my algorithm will run for shit. My algorithm will run for these numbers, these 2, 5, because these are even. And how can I optimize it further? Yes, the series does matter because if it were 2, 4 instead of 4, 2, then 2 would run for something like this, and 1 would be added to this. 0 would be added to this, and 2 would run for something like this. And if something was a remainder, was like divisible by 4, it would not be divisible by 4 anymore because 2 would be added to this, and this would become 50, and 50 is not divisible by 4. Check. So the order of these queries does matter. So I have to see a number, uh, then all the numbers that are smaller than that. So right now it is 10, 4, 2. And if a number is divisible by 10, it will be divisible by 4, divisible by 4, and it will be divisible by 2. Mm, mm, So it will be changed 3 times, and I can add those 3 changes in one go. So while taking the input, if I can store it in such a way that would make this information accessible to me, like for every number, what are all the smaller numbers than this number to its right, and then smaller numbers. Calculating that would also take time. Yes, it would take n square time, which is already what I'm doing. So it would take q square time, not n square. Mhm. I can do dynamic programming here, a little bit of dynamic programming to calculate this thing, this part. And once I have calculated this part, it would be easier. I can do this calculation in just log of, in just big O of n, and that would be cool. Dynamic programming. Hmm. Outright taking the second input. Yes. I'll make vi no vector of int 6. That is a big vector. Vector of int 6 sml small q q. Nothing for the last one, by the way. And then I would need a function, another function, which would return void and find sml. It will take an index, and let's say our vector of int 6 sml. So, and what will it do? It will find the smallest for int I, and initially let's make all of these equal to -1. So equals uh, size n, everything is equal to -1 initially. And here for the ith index, right? Yes. And so while I, okay, int j equals I plus 1, and while j less than sml dot size, and not sml, but I will also need this thing, the inputs. So vi, it is x, vix, x smaller, while x j is greater than or equal to. But if it is equal, if it is equal, then no, then it will not work. While it is, if it is equal, so yeah, and then just move forward. Do this, and equal to or greater than the current one, which was x I, while this j plus plus, and anything else? Nope. Once I have found the way, if j lower than sml dot size, then I check one thing, a few things. If if SML of j already exists, if it is not equal to -1, then SML of the current number becomes equal to the SML of j. I know that when getting to j, SML of j will be added plus SML plus 1 left shifted by x I -1 times, else SML else find SML of j with SML uh, find SML for j, pass in SML and pass in x, and copy by reference, uh, is this cool? I mean, yeah, so, okay, only the handler will be copied. This, and one more thing, after finding this, if it is equal -1, then do this and then do this. If this, else SML I equals, there is no number that is smaller than this, so it will be just 1 left shifted by x I -1. Is that cool? Yes, that is cool. And do this if SML of I equal -1. Now, after this, I can call repeat L 0 till n until q, find, it is not declared, c q, find SML of I SML x. After that, I just have loop once, I think, 0 through all the elements, and find this list, and keep moving, keep moving in the query until that is also not very optimized. That is also not very optimized. Mm, mhm. Not very optimized. No, no, no. Nope. I will find the think. I think when I can make this pair a vector uh, pairs and take into first and x output like first and here whenever and while inputting this thing I'll make that no, no, it will take n square time. It will take fucking n square time finding the smallest number. Mhm. Mhm. Shit. In this, if not a remainder of 2, that is, if it is even, shit, repeat L, I, 0, J, 0, A, L, what the fuck, Q times, and find the number that is the smallest, right? Uh, 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 int J equals I plus 1, and Y J lower than Q, and E X J divisible by current element, and not a remainder while there is a remainder, right? Yes, while there is a remainder when trying to divide A I divided by the current J, which would be n left shifted by x j amount dot first, and I can remove that thing that thing from here. This vi and this while this while there is a remainder, keep moving, and at one point there will not be a remainder, and when that comes I will be out and I will have j. Now if j is lower than q, that is I do have a divisible thing, and if that is true, then j is the one that I divide with, and so a I plus equals sml of j, else don't do anything. Let's see, and wrong answer. Hmm. This thing shouldn't even have changed. How is that feeling? It's a SML. I did -1 there. If it is even, only then. Oh shit. Okay. 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 My bad. My bad. J starts at 0. We are traversing two different arrays. Mm-hmm. Still wrong. Still, still wrong. Is it wrong? I'm initializing it here. N minus 1 and y minus 1 plus smg and smj initially is initialized here. Okay. Shit, something is wrong. Yeah, what are you teaching? Are you Indian? Seems like I am Indian and I'm just programming, trying to program. I'm not trying to teach. This doesn't seem to be working. I have figured out a brute force way, but that is always easy. Let's see the editorial. Debugging. Let a be divisible by 2 power x. Let a number be divisible by 2 power x. Then after applying the operation, it is no longer divisible by 2 power x. From this, we can conclude that if applying the operation xi, there is such an operation uh, smaller than I, that yes, okay, then the operation I does not change the array, yes, so it is useless and can simply be not processed. Then we will maintain the minimum of the processed x. If minimum of the processed x, okay, yes, okay, if the new operation is smaller than the minimum processed one, we will process the operation and update it. Otherwise, we just won't do anything, since the minimum process will decrease at most 30 times as the time complexity is better. Since the minimum process will decrease. Okay, so are they saying to go from process to process? For 10, I go through the whole array and shit, that makes sense instead of going this shit. Yes, yes. That does make sense instead of going that way. After taking in the input, I can remove all of this and int mn is equal to x0 and then repeat li 0 goes to q. I will go through all of that. Process, process, okay, and go through the array if it is smaller than, or if it is only if it is smaller than the last one. And I initially it can be, let's say, 31, doesn't matter. And yeah, if xi smaller than mn, only then go through this, and at then mn equals xi, and what, repeat this j0 n and go through the array. If a j, if no remainder with a j divided by 1 left shifted by xi amount. Yes, xi amount. There is no remainder is divisible, and if it is divisible, then aj plus equals 1 left shifted, or more like 1 left shifted by xi minus 1 amount. Right. uh, that is cool. Mn and mn means xi makes sense. I think this is cool. And let's see. And this is actually cool. This works. Let's full see it. Submit. Submit, and let's see. Accepted. That is cool. That is actually pretty fucking cool. And how long has it been? 2 hours and 36 minutes. I think I can do little quiz now. Yeah, I did 3 questions today and I was unable to optimize this one. And okay, today's stream can be this long, 2 hours, 2.5 hours. I would make it longer, but today I also have a competition. So yeah, that is theory of today's stream.